How many times do the following lines intersect? We have our first line here and our second line here. We know how to sketch the first line because this equation is in slope-intercept form. We have the y-intercept of 3, and a slope of 2 is quite steep uphill. 2 over 1 means you go up 2 units and you go 1 unit to the right. Now if you rearrange this equation, we get 3x minus 1 equals 2y, and we can divide both sides by 2. We get 3 over 2x minus 1 half. So as you can see, the slopes of these two different lines are different. Here we have 3 over 2, and here we have 2. So when we have different slopes, right away we know there's only one solution. Let's draw this out here. Negative a half, the y-intercept, means that we're below the x-axis, and the slope is slightly less steep. So this original line will just extend it out just a bit longer, and this line here will just draw it out something like this. We can see that there's only going to be one solution. Let's use algebra in part B to isolate for y. We have 2y is equals to 4x plus 12. We divide both sides by 2. We have y is equals to 2x plus 6. So we have the slope and the y-intercept. So 6 is around here, and we'll just say uphill, like this. Now the second equation is y is equals to 2x plus 6. That's the exact same equation we just arrived at previously. So the second equation is right on top of the other one. We call this coincidental. These lines are coincidental. This means that there are an infinite number of solutions. There are an infinite number of dots in which these graphs collide. Let's try part C. We divide both sides by 2. Y is equals to 2x plus 1.5, which is the same thing as 3 over 2. And we know how to sketch this. So 1.5 we'll say is around here, and a steep upward graph, slope of 2, looks like this. So what we notice here is the slopes are the same. They're both 2 for these lines. However, for this second line, the y-intercept is different. We have a y-intercept of 5. So we'll say 5 is up here. And as you can see, these lines are parallel. Parallel. So there's no solutions. These lines never hit. Finally, let's look at part D. We have the straight line x equals negative 2, which is here. The origin, by the way, is right here in the middle. And our other line is y is equals to negative 2x plus 4. So we'll say the y-intercept is 4 here, and a slope of negative 2 is downhill. So we'll just say something like this, just to make it a bit more accurate. And notice how this red line extends up all the way such that there's one solution. We have different slopes. We have a slope of infinity, undefined, and we have a negative slope. So there's one solution.